All right, so this is Algebra 1. This is our last lesson for this unit, and then we have a quiz tomorrow on Wednesday, and then we have a test Thursday and Friday, and then we begin our brand new unit when we're back in person. So today's date is Tuesday, January 12th. So January 12th, 1/12/2021. If everyone can have their cameras on, I'd really appreciate it. Unless you want to send me a private text message, whatever, somehow let me know if there's a problem with your internet or camera. Otherwise, I have to take off points for your behavior grid. Okay, there's a lot of reading for this one. So who can read the entire first paragraph and this first question ending with right and inequality representing the condition based on the number of eggs? Yeah, Diego.
It takes 1 egg and 1/2 cups of sugar to make one batch of cookies. It takes 2 eggs and 1 cup of sugar to make one cake. Drew is a chef who needs to make at least 5 cakes for a wedding and makes and wants to make at most 7 batches of cookies. Let A represent the number of batches of cookies and let B represent the number of cakes. Write an inequality that represents the condition based on the number of eggs.
Beautiful reading. Thank you. So that sounds like a much harder problem than before, than yesterday, 6-4 notes. And I got your message, Haiti. Thank you. So we can see that our variables are going to be A and B. Those are going to be the things that are going to be in our equation. So we can see that, yes, if it's only asking for eggs in this one, then this one is only going to be asking for cups of sugar. Those are how you're going to define your two inequalities, because there's so much information here. It makes sense that you're going to have somehow two inequalities. So somehow our first inequality is going to have the capital letter A, it's going to have the capital letter B, and it's only going to be talking about eggs. So that's kind of the trying to limit our focus here. So I'm going to go ahead and zoom in now so you can see what's going on a little bit better. So typically speaking, you are just going to have a coefficient in front of these letters. So like a number A, like 7A plus, I don't know, 5B. Did I just give away the answer? I realize I'm using the same numbers. Maybe it's like 9A plus 3B. And then somehow you're going to have an inequality and make sure that it's the right number. So I'll let you guys kind of read over that once again, and then I'll ask for a volunteer on what letter gets attached to what, or what variable gets attached to what number. So as a hint to you guys, I'm going to underline everything in blue for my first question here. So I'm going to just maybe shade the color blue here to let you know this is my blue question. So eggs, there's 1 egg and 1.5 cups of sugar to make one batch of cookies, which means 1 egg for a batch of cookies. I'm only looking at eggs. I'm going to kind of ignore the sugar for now. That's going to be the next half. And then the next one is going to be talking about 2 eggs for 1 cake. So those are the 2 pieces that are going to be used to make the correct number of cakes. And again, since we're dealing with cookie or cakes and cookies, we have to be a little bit careful. How could this affect our variables here? So this is 1, but it's talking about 1 for a cookie, right? 1 egg per cookie. So if A represents the batches of cookies, you could say 1A, because there's 1 egg and that makes 1 batch of cookies. So 1A, this is now representing the batches of cookies, or the number of eggs per batch of cookies, by saying 1A. I'm literally attaching this 1 to this A because it's 1 egg per batch of cookies, and A represents cookies. So I'm going to add a quantity of eggs with another quantity of eggs, plus another quantity of eggs. Does anyone have an idea what I should write in this spot? This is going to represent the number of eggs that are used per cake. cakes don't require 1 egg, they require more than that. Yeah, Alden?
I can't see if you're writing.
Yeah, me neither.
What?
I think you froze the computer.
That's strange. Here, let me stop sharing and then I'll reshare. Stop share. Was it just showing a picture of my camera the entire time?
It was just the notes, but there was no writing on it.
Is it showing writing right now? Like if I draw, does it do anything?
For me, it just says Mr. Sindel has started
Yeah, that's what
screen sharing.
it says. Mr. Sindela has started screen sharing.
What's going on here?
Oh, there it goes.
It works.
No, we could-
I haven't touched anything. I'm literally just staring at my screen. Something new happened? What happened?
We can see the notes with the marker and stuff on it.
Can you see me drawing like this now?
Yeah, squiggle lines.
Yes.
That's weird. I literally haven't done anything aside from just kind of looking at my screen. Maybe Zoom is hiccuping. Well, sorry about that, guys. Okay, well, let me run through that really quickly again. I'm just kind of analyzing this problem. I'm saying how many eggs are used for every batch of cookies. It's 1 egg for every batch of cookies, so it's going to be 1A. And then it's going to be 2 eggs for every cake. And again, cakes is going to be B. It says B, it says cakes. So there's going to be some coefficient in front of our B. Some number here in front of our B. If 1 was attached to A because it is 1 for every cookie, what number is going to be attached to B?
2?
It is going to be 2, but if you could do a quiet raise hand next time, that would be better. Yeah, it's going to be 2B because it's 2 eggs for every cake. So this is representing the total number of eggs for every cake. So this is for cake, because why is it a cake? B represents cake. Okay, so this is now representing the total number of eggs.
We had to write the example on the notebook, right?
You
Like-
probably want to abbreviate, yeah, because writing all of this down is kind of intense. And I know, like, if you're in person, they can just hand this out and you wouldn't have to rewrite it all down. So try to abbreviate as much as you can. I would write something along the line of, okay, cookie, 1 egg, 1.5 cups sugar. The end. You don't have to write down a complete sentence. You don't have to write down every single thing. Okay, so we'll come back to this in a sec, but let's try doing the same thing for sugar. What's going on with our sugar equation, or inequality, I should say? Any ideas for what we do? You're again going to be using the variables A and B. You're going to be adding these. You want to see how many cups of sugar is required for cookies, how many cups of sugar is required for a cake, but what number is attached to the cookie variable, judging from our problem up here. And again, this is all representing cups of sugar now. I see multiple hands now. Yeah, Giorgio.
For A, 1.5 cups of sugar.
Yep. So this is saying 1.5 cups of sugar for every cookie. Okay. And then what about for capital letter B? Ashley?
1 cup.
Exactly, yeah. Because it says 1 cup of sugar and then 1.5 cups of sugar. Perfect. Now the challenging thing here is how do we make this into an inequality, something that actually makes sense, something that we could help solve. So, and that is what I'm also struggling with too. How does this make sense? Because if we're writing a condition based on the number of eggs, what should the maximum number of eggs be? Well, it should always be, we haven't used this information over here. We haven't used the fact that there should be at least 5 cakes and 7 cookies. The problem is this is mixing up our cookies with our cake. I feel like maybe the problem is not asking the question correctly, because it makes more sense to me to purely talk about cookies versus cake instead of eggs versus sugar. Give me 1 sec. Let me see if this would make more sense. I don't know if this, because this is a problem that was made well over a year ago. Would it make more sense to actually ask the question instead of number of eggs? Let me test this out. What would happen if I did instead just cookies? Because we know that the maximum number of cookies is 7. So if I change this problem to say cookies, then we'd say, okay, we want to make less than or equal to 7 cookies. And then what is the thing that's attached to cookies? You'd have variables of eggs and sugar. So you'd say like something along the lines of 1 egg plus 1.5 sugar has to be less than or equal to 7. Yeah, I think this problem is all messed up, guys. So, I mean, knowing that if the problem was correct, this is exactly what you would want to do. You'd attach whatever variable to the correct number that's in the problem. Unfortunately, the problem was written incorrectly, and I feel very sad that all that work that we did is kind of in vain. But we have to now kind of, I think I'm going to skip over this problem because otherwise I'm going to confuse the heck out of you guys. So it was good work, good legwork. Unfortunately, the problem was asked incorrectly. So I'm going to kind of skip to the next problem. Sorry about that. Hopefully this next problem actually is written correctly. All right, can I have another reader to read this one, please? Diego read the last one. Is it possible to get a new reader? He was really good. Yeah, Ripley.
Jordan is building desks and chairs. Jordan has a total of 100 wooden boards and 250 nails. 15D plus 5C is greater than or equal to 100, represents the number of desks D and chairs C. Jordan can make with 100 wooden boards. 30D plus 20C greater than or equal to 250 represents the number of desks and chairs Jordan can make with 250 nails. Does Jordan have enough chairs or enough boards and nails to make 4 desks and 7 chairs?
Okay, so there's a lot of things happening in this problem. But I think this problem is a lot easier than the previous problem because you literally just have to plug in. Thank you for reading. That was awesome, by the way. And one thing that I would point out too is the symbol is actually less than or equal to instead of greater than or equal to. Less than because the alligator doesn't care about this less than thing. It wants the greater than over there. So the way that I would go about this is I would make sure that I have my variables correct. So D is desks. So desk says D. So when it says 4 desks, that means D capital D is equal to 4. I'm going to plug in 4 in the space of D. And same thing over here. 7 chairs means capital C is equal to 7. I'm going to be plugging 7 in for the spot of C for each of these inequalities. They both have to work because otherwise the problem doesn't make any sense. Like if one of them doesn't work, then you don't have enough. All right, so let's start plugging into our first equation, our first inequality, I should say. So I'm going to rewrite this left-hand side, but in the space of these variables, I'm going to leave some empty parentheses. So I'm going to write out 15 and then parentheses, that's where our D would go, plus 5, and this is where our C is going to go, is less than or equal to 100. And as I said before, our capital D is 4 in this case. So 4 gets plugged in. And again, capital C is 7. 7 gets plugged in right here. And we have to verify, does this left-hand side, is it still less than or equal to 100? And I'll also write a little note, just to make sure we know that we're on our first equation. This is representing desks and chairs you can make with wooden boards. So this is kind of the key thing. This is for wooden boards. Why is that important? Because if this inequality doesn't work, then you're going to say there's not enough boards. There's not enough, or they have enough boards. So there's not enough boards, something like this. So if this doesn't work, you'd say something along the lines of there's not enough boards. All right, and this is just purely mathematics. So multiplying by 4, the cool little trick is multiplying by 2 twice. So 15 times 2, 30. Then double that again, 60. So 15 times 4 is actually 60. Then 5 times 7 is 35. Less than or equal to 100. And I realize I'm kind of doing the math for you guys. 60 plus 35 is 95. It's less than or equal to 100. Here's the important part that I want help with. What does this mean? What does 95 is less than or equal to 100 mean in the context of this problem? Does it mean I have enough? I don't have enough? Of what? I see one person has an idea. I see Alden's hand. Does anyone else have an idea? What does this mean? 95 is less than or equal to 100? 2 people have their hand raised. Yeah, Diego, talk to us.
This shows that he does have enough boards and nails to make 100 wooden boards. Wait, yeah, wait. No, this shows that he has enough to make. Never mind. I don't know.
You're really close. The first half of your statement was perfect, but then you kind of messed up a little bit at the end. You originally said he has enough to make, and then you said wooden boards, but he has enough wooden boards to make what it says here, to make 4 desks and 7 chairs. And this is only talking about wooden boards. We're not talking about nails yet, because this second inequality is going to talk about nails. So I'll write the conclusion underneath this, or maybe I can even type it to make it go a little bit neater. There are enough wooden boards. That's as simple as I can make it. But are there enough nails? I don't know. We'll have to check the second inequality. And I realize I took up more than half the room, so I'm gonna have to squeeze it over here on the right-hand side. Because again, this equation represented wooden boards, or this inequality. I keep saying equation. So this second inequality, I'm going to go ahead and rewrite yet again. This is going to be 30D plus 20C is less than or equal to 250. 30, that's our capital D. I left an empty parentheses, plus 20, that's going to be our C. I know I'm running out of room here. That needs to be less than or equal to 250. And plugging in yet again, our capital D is supposed to be 4. So plugging in 4 right here, plugging in 7 for the next spot. I have to verify, is this true? So if you don't know how to do multiplication, then you have a calculator. So I'm not too worried about this. I'm not quizzing you on how to do 30 times 4, but 3 times 4 is 12. Add the 0, that's 120. 2 times 7 is 14. Add the 0 again, that's 140. I need to add these two together, and hopefully they will be less than 250. So 100 plus 100 is 200, and 20 plus 40 is 60. So I get 260 is less than or equal to 250. So like the statement that I made previously, there are enough wooden boards. You will either say there are or are not enough nails. What does this inequality here mean? I see one hand, I see two hands. Ripley?
There are not enough nails.
Exactly. There are not enough nails. Cool, and then we just have to find the option that says there are enough wooden boards, but there are not enough nails. And that's option B. It says Jordan has enough boards, but not enough nails. Give me a fizz of 5 on this second example that we did. I'm seeing 4s from everyone. I can't really see.
I'm like
can I
about
see
like 3.
3, okay. Does anyone have any questions that I can help clarify anything? No, okay, let's go on to example number 3. So this is the graphical representation of everything. All right, I need my final reader of this unit. I already got Diego and I already got Ripley. Can I get a new reader? Is that possible? Yeah, Haiti.
Taylor is working in a kitchen to have enough prepared food for meals. Taylor must peel at least 30 vegetables. Condition A with a time limit of 10 minutes. Condition B. The graph represents the constraints on the number of potatoes, P and carrots, C, almond peel.
Oh, whoops, I forgot to change the name there. Sorry about that. We're talking about Taylor, not Eamon. So Taylor can only peel so many vegetables. We're talking about potatoes and carrots. So we know that vegetables, Taylor has to peel at least 30 vegetables. So I have to be above some amount, and that's condition A. So you can see in terms of the graph, I'm helping you guys interpret the graph right now. Taylor has to peel more than 30 vegetables. So something above 30 vegetables, that's condition A. It says condition A is peeling at least 30 vegetables. So everyone can see on the graph, okay, A means I'm above this red line right here. We're all okay, we nod our heads. This condition A means we have to be somewhere up here. And then condition B, this condition B means there's a time limit of 10 minutes. I have to be beneath 10 minutes. I have to be beneath that line down there. So let's go ahead and read the question. The question asks, what is the greatest number of potatoes Taylor can peel to meet both of Taylor's constraints? The greatest number of potatoes. And you can see, I haven't helped you analyze the axes yet. P represents potatoes and C represents carrots. So if I just chose a random point on the graph, this point right here, this point on the graph means that there are 25 potatoes and 50 carrots. Any point on this graph is going to not represent time and height or anything like that. It's going to represent potatoes and carrots. That is it. There's nothing else that's given by this graph. Purely potatoes and carrots. So you right now are looking somewhere on this graph I'm trying to maximize potatoes. I'm trying to go as far right as possible because potatoes is to the right. What is the farthest right that I can go that is in the shaded region that is the solution to the answer? Again, in order to have the time constraints, I have to be in this region. In order to peel enough vegetables, I have to be in this region. The only way that answers both questions is to be in both regions in this little shape right here. What's the farthest right that I can go with this double shaded region? What's the farthest right I can go? And then how many potatoes is that? I see Giorgio has an answer. Anyone else have an answer? Go for it, Giorgio.
Could 15 work?
15 is the answer. Yeah, how'd you get that?
Because it's the line is solid, which means it's equal to, so you can put it basically on the lines, and the lines are intersecting, so you can just put them right there.
Yeah, so again, we have to be somewhere in the solution set. The farthest right that we can go is at this spot right here.
15 carrots and like 15 potatoes.
Yeah, exactly. So, and you can see that's 15 potatoes and around 15 carrots. And I like Georgia's analysis also that they're both solid lines. So you are allowed to be on the line. If they're dashed lines, maybe it'd be like 14.999 or something like that. But I'm going to leave this point on the graph because this represents the maximum number of potatoes. All right, let's read the next question. So Taylor peels 10 potatoes. Just know that. What is the range of carrots that Taylor can peel to meet both constraints? Again, to meet both constraints means I am in the double shaded region. So I'm in that double shaded region, and I know for a fact Taylor has peeled 10 potatoes. So again, 10 on this potato axis. I am at 10 potatoes. What is the range of carrots that Taylor can peel? Between what and what? And as a hint to everyone too, if I were to draw a line that represents 10 potatoes, it's this green line right here. This green line, any single point on this line, this point represents 10 potatoes and 62-ish carrots. This point right here represents 10 potatoes and 50 carrots. This point right here represents 10 potatoes and 40 carrots. Every single point on this line represents 10 potatoes. But it needs to be in the double shaded region. So what is the range that I can be in the double shaded region? My God, my phone is blown up. Alden.
25.
25. 25 is an answer that I can have, but I'm looking for a range between what two numbers? Between 25 is in that correct range, so you have that right, because 25 carrots is right here. 25 is on the green line, good, and it's in the double shaded region.
Between 20 and 30.
Between 20 and 30, exactly. Between these 2 points here and here. So we can say between 20 to 30 carrots. Nice. So those are a few examples that you can see on the homework tonight graphically. And I'm really sad that our first equation or first example was off by a little bit. Hopefully people at least took a little bit away from it. So there's our notes. again, example 1 didn't work. You can, if you had anything written down, you can kind of cross it off. I have to rewrite it for next year. Sorry about that. Give me a fist of 5 on how well you can interpret inequalities and answer questions about them, word problems. Again, a 4 from Haiti, 4 from Ashley, 4 from Ripley, 4 from Alden, 4 from Giorgio. Okay, Jose, you cut out right when you said your number. Four from Diego, 3 from Jose. Got it. Okay, cool. Well, again, I can't apologize enough. I feel very guilty that I had that mistake 2 years in a row now. Let's go ahead and stop the recording.